So welcome to today's lesson, and we're going to be looking at long division. Now, I'm a kid of the 80s, and if I remember sort of the long division way back in time, something called Standard 8 or Grade 10. And yeah, so it's a pretty straightforward process. Eager to take you through it, and basically so that you get a better understanding of the algorithm and that you master this, because it's such a crucial little section when it comes to things like Laplace transforms, partial fractions, and the like. So let's get on with this simple topic. Oh, airbag, save me from this monster. What is this? I thought we were doing long division, not just writing some sort of alien code. P of x, well, that's just a polynomial. Polynomials, familiar with this stuff? Ax squared plus bx plus c, we've studied this, we've drawn these graphs, parabolas. Polynomials are really cute. They're well behaved, they're differentiable, they're continuous. So they're really nice little things in mathematics, very easy to deal with. So what we're claiming here is take a polynomial p of x, and that can be written as a of x times q of x plus this term r of x, which is the remainder. A of x turns out to be what we call the divisor. So we're going to have a look at this, but rather than look at it from a general point of view, I'm going to start off with a very simple example. I think that will illustrate the method as well as explain what's written over here in front of us. So let's get on with long division. Okay, this looks familiar. X squared minus 2x plus 1. And the question really is taking that polynomial and you're dividing it by x plus 3. So we are going to do this very simply just to illustrate the method of long division. And so we're going to go x squared minus 2x plus 1. The divisor x plus 3 over there. And the chappy sitting inside there is called the dividend. And once we divide through, we're going to get something called the quotient. So x squared minus 2x plus 1 divided by x plus 3. Let's illustrate the method. So if we look very carefully here, the first term here, it's ordered 2 power 2, so it's x squared divided by the first term of the divisor. So we're just going to put this out here, do some bookkeeping. X squared over x, no prizes for guessing, is x, and that sits out there. So what we do after that is to take it back in. So what we do is we take the x and multiply it by the first term, the leading term of the divisor, and what is x times x, which is x squared, with a plus sign over here, so there's a plus, and was x times 3, which is 3x. And you would have seen books do that. And the reason why we do that is a little subtraction. So what is x squared minus x squared? Be careful here. That's going to be 0. What is minus 2x minus 3x? Minus 5x. Now, what's remaining there is a plus 1, so you're bringing that down. Okay, so you got minus 5x plus 1. Now, when do we stop? When do we stop dividing? Well, look at the order of the leading term here. It's 1, and the order of the leading term there is 1. So if the order of the leading term is equal to or more than the order of the leading term of the divisor, remember this is the divisor, you continue dividing. So what is minus 5x over x? Let's do some housekeeping again. Minus 5x over x, here, minus 5. And so what we end up with is a minus 5 there. Okay? And what do you think we do next? We simply take that minus 5 and then we multiply it by that leading term. So what is minus 5 times x? You would have guessed is minus 5x. And don't forget the 3 there, so minus 5. And that becomes minus 15. We're going to do some subtraction over here. And for sure, as God made little apples, minus 5x minus minus 5x is going to be a 0. And 1 minus minus 15, be very careful. I'm going to put a plus sign. So that's 16. Now, there's no terms involving x there. The order of this remember, is x to the power 0, which is less than 1. So we stop, and that's it. We are now complete with our long division. But what have we proved? What have we accomplished? Well, what we've done is, interestingly, took x squared, and here's my claim, minus 2x plus 1. And that I can write, remember the previous slide, that monster of an expression? Yeah, that's the divisor x plus 3. There we go, this chappy. And we're going to multiply that by x minus 5. And that r of x is now a constant. And that is the remainder. Now, test it. Look at the right-hand side. Multiply the two brackets out. Add 16 to it, and you'll get the left-hand side. Another way of doing it, in keeping with the question that we had originally, is to go x squared minus 2x plus 1 all over x plus 3. That's going to be x minus 5 plus 16 over x plus 3. It all makes perfect sense. It is so simple. Let's do another example. When you thought it was safe to get back into the water, they throw you something like this. What happened to that cute sort of quadratic, that parabola that we all spoke about, ax squared plus bx plus c? Why is life not that simple, or always that simple? Well, we live in the real world. So here we go. We've got a fourth order polynomial. We're dividing by a linear factor, x minus 1. How bad can that be? Let's just go for it. Let's throw ourselves into this thing. And so we go x to the power 4, remember, plus x cubed minus 3x squared. You'll be surprised at how many students make the mistake of taking down a question incorrectly. So always check, have I got that down? X to the power 4 plus x cubed minus 3x squared plus 3x minus 2, and the divisor is x minus 1. So the leading term, if you have a look very carefully, is x to the power 4 there, and the leading term in the divisor is x. So some housekeeping, x to the power 4 over x, and that's going to give me a nice x cubed. Okay. So where does the x cubed go? Well, it's going to go up there. Do you remember what we did next? Well, we're going to multiply that back in. So we're going to go there, and we multiply. So x cubed times x is going to give me x to the power 4. And don't forget the minus 1, sitting there all alone. So that'll be x cubed times minus 1 becomes minus x cubed. And here you've got to be very, very careful. X to the power 4 minus x to the power 4 is a nice big fat 0. X cubed minus x cubed is 2x cubed. You bring this chappy down, so it becomes minus 3x squared. Leading term there is 3, order there is 1, so we continue with the division. Some housekeeping again, 2x cubed over x is 2x squared. Take that, put it up there. Now you don't have to go all colorful like this. I'm teaching, so I want you to understand what I'm doing. What's the next step? Well, you're going to multiply this by each of the terms out there. So 2x squared times x is going to be 2x cubed. 2x squared times minus 1 is minus 2x squared. And then you're going to subtract. So 2x cubed minus 2x cubed, big fat 0 there. Be careful here. Minus 3x squared minus 2x squared is minus x squared. And bring this chappy down, plus 3x. Order 2, order 1, continue dividing. So minus x squared over x is minus x. Housekeeping. This for you now. X squared all over x is minus x. Multiply the minus x out there. So minus x times x is minus x squared. Minus x times minus 1 is plus x. And we're going to subtract. So that's going to be a 0. 3x minus x is 2x. Don't forget, bring that sharpie down. So that's minus 2. Oh, we're almost there, almost there. Look, order 1, order 1. So 2x over x. 2x over that guy is going to be plus 2. Then you're going to multiply back in. So you're going to get 2x minus 2. Yay! That's interesting. What just happened there? Well, what we just proved is really, really cool. And that is that this polynomial, x to the power 4 plus x cubed minus 3x squared plus 3x minus 2, when divided by x minus 1, goes in exactly this number of times. That number of times there. The remainder is 0. How cool is that? Well, as I said, you know what? This is just one class of problems, and you notice the divisor is linear. What if you are dividing by something like x squared plus 2 or x cubed minus 2x plus 1? Okay, so watch this space. Please pause, review, stop. Make sure you understand each of the steps before proceeding. Awesome, guys. So we shall see you on the other side of 10, whatever that means.